Hello and welcome to JHEP's lesson on redox using iodine and thiosulfate. So the first thing I want you to do, if you haven't read this question before, is to pause the video and read it right now. And when you come back, the two tasks that we need to do is to write ionic equations for steps 1, 2 and 4 and to determine the percentage by mass of copper. So the first thing we've got to do is to have a look at step 1, and it says that we've got this mass of brass which reacted with an excess of concentrated nitric acid. And that's important. Excess is the important word for the next part. And we've got half equations over here. This half equations, all we've got to do whenever we see that, just join them together. You need to verify that the number of electrons are the same on each one. Obviously they're not the same here, so we need to times this whole row by 2. And when you put them together, it would make this. If you're not sure how to do this, please look at my redox equations video. So the second step says that excess aqueous sodium carbonate, which is, if we break it, because we're looking at ionic compounds, so if we break it up ionically, Na2 plus and CO3 2 minus, is added to neutralize any acid. Okay, so let's just look at that first sentence. Obviously, a precipitate forms and a mixture effervesces, but let's look at this sentence first. So, we obviously have an excess of acid. So, with all of this in the solution right now, we still have HNO3 in there as well, because it is an excess. So, what we've got to do, we've got to split that HNO3 into ions, which is H plus and NO3 minus. And we've got to figure out what is going to react with what. And obviously, seeing as it is an acid, we are going to react this H plus, because it's obviously donating protons. So we're going to react this H plus with a base, and it's obviously not going to be sodium, so it has to be CO3 2 minus. But the only problem that we have here is that we've got one proton here, whilst we need 2. So therefore, what we do, we balance it out by writing 2H. And seeing as we're only focusing on this, what we do is to write down 2H plus CO3 2 minus goes to, and it tells us that it effervesces. That means it bubbles. That means we've got CO2 coming out of there, because we can make CO2 from here, and we've got H2O. The second thing that happens is that, seeing as this is in excess, we have carbonate, sodium carbonate, which is over here, reacting with whatever is available here to react with. And as you can see over here, copper 2 plus is very available to be attracted to the carbonate. So we have the Cu 2 plus the carbonate, and that would go to CuCO3, copper carbonate, like so. And that is our precipitate. So we've got our effervescence and we've got our precipitate. The last one is not that hard. All it's asking us to do, I can't draw straight lines today. All it's asking us to do, no, I really can't draw straight lines, I'm not going to bother. Yeah. Oh wait, here we go. All it's asking us to do is, if I read it first because I totally forgot it, is that it's adding aqueous potassium iodide. Now this, basically we just need to remember it, rote learn it, or we can do it like this. So a 25 centimeter cube sample of this solution that we just made is pipetted into the conical flask, and an excess of aqueous potassium iodide is added. Now the ions in question are the Cu2 plus and the I minus. Obviously there's other things reacting with it, but seeing as this is an ionic equation, we are only interested in the ions which are going to make something different and which are not going to be spectator ions. If you don't, a spectator ion just does not take part in a reaction, basically. So we've got Cu2 plus I minus, and it tells us that iodine is formed. So we got I2. And obviously, if you don't know, copper 2 plus does get reduced to copper plus. So now we need to find out how many iodide ions we need to complete it. If you're not sure how to do this, please refer back to my previous video on redox using iodine and thiosulfate, because we did come across that over here. And we found out that we would need 4 iodide ions. So we can have 1 iodide ion here to make an oxidation state of 0, and we can have a full one here. Obviously, we can make those copper 2. So we have 2 iodide ions here, 1 molecule of iodine, and there we have it. Again, please look at my other video because I explained it in a bit more detail than that. And that is our 3 ionic equations, or 4, because it's 4 marks, so it needs to be 4 ionic equations. Now the next bit is just asking us to determine the percentage purity of the copper, or how much copper there is in this brass. So what we've got to do is to read it properly. So we've got all of this, and the precipitate is reacted to form a solution which is made up to 250 centimeters of water. Now, pretend that it's actually in your hand. Pretend we've got 250 centimeters cubed solution. What we're going to do, we're going to pour 25 centimeters cubed of that solution, and that's important because we are only using 1/10 of the moles which are in that volumetric flask. So keep that in mind. So we have got, in step 4, we've got this equation over here, and then the most famous equation that you should know is actually in step 5 for you, which is I2 plus 2 S2O4, if I'm right. No, S2O3, sorry, I beg your pardon. So it'd be I2 plus 2 S2O3, and that would be 2 minus, to make 2I minus plus S4O6 2 minus. This is something that you do need to remember. Luckily, it is in step 5 over here. So it's telling us that this resulting mixture is titrated with this concentration and with this volume. So we have 0.1 moles per decimeter cubed, and that's our concentration, and we have 0.0298 decimeters cubed, which is the volume. If you don't, to change from centimeters cubed to decimeters cubed, you just divide it by 1,000. Now, instinctively, I have got CMV. I can literally find out what the number of moles is. Instinctively, it should be one of those things that you just do automatically without the question asking you. And all we've got to do here is to multiply that together, and that will make 0.00298. So this is the amount of moles of thiosulfate that has reacted with the iodine that has been reacted with the copper 2 plus. So for every mole of I2, we have 2 moles of that reacted. So what we have to do is divide it by 2, and that would make 0.00149. So this is the amount of I2 that has reacted in the 25 centimeters cubed solution. Keep that in mind. Keep it in mind. So the molar ratio, so that's obviously the molar ratio here, 0.00149. The molar ratio is 1 to 2. So we've obviously, for every 2 moles of this that's reacted, it has produced 1 mole of this. So you times this by 2 to make, I'm going to run out of space. Okay. To make, I'll write it here. To make 0.00298 in a 25 centimeter cubed solution. Remember, we only used 1/10 of that solution. We have still got 9/10 of that still in your hand. So what we need to do is to multiply this by 10 to get 250 centimeters cubed, and also multiply this by 10. So in a 250 centimeter cubed solution, we have 0.0298 moles, and using that we can find out the mass that has reacted. We know what the MR is if we look at the periodic table, which I haven't got for some reason, but the periodic table shows us that the AR of copper 2 plus is 63.5. And using N equals M over MR and rearranging it to be N times MR equals M, we can find out what the mass is by multiplying this together to make, what does it make? 1.8923. Let me just double check that. I like to double check stuff. So it'd be 0.0298 times 63.5. So this is the amount of copper in the brass. It's asking us for percentage relative to the amount in brass. So all we've got to do is do 1.8923 divided by whatever it says at the top, which is 2.8. And that answer, oh, don't forget to times it by 100 as well because it's percentage. And that answer is 67.56. But seeing as it asks us for 1 decimal place, it will be 67.6%. And that is it for this question.